but I'll go ahead and start recording. And again, everyone, thank you for joining us. This is Dr. Subramanian Ramachandran. Again, he is one of the professors at the University of Washington, Bothell. Usually he teaches a lot of the experimental courses. Had the privilege of taking at least 2 classes with you. But really great instructors. So thank you again for joining us today.
Yeah, thank you. And I see a lot of familiar faces. I see Joel, Tim. Yeah, I haven't met Espinoza or Antonio.
So one of kind of the neat things is we were like, we really wanted to try and branch out as much as we could. So we started making our workshops available to the whole national organization of Sigma Pi Sigma. So Diego and Antonio are actually from different schools.
Oh, nice. Okay. Yeah. Okay. Yeah. Yeah. Welcome to the cyber world. Yeah.
Thank you.
So, all right. So I'm going to, yeah, welcome. So where are you at, if I may ask? Yeah, Espinoza, Diego, sorry. Yeah.
Tonio and I are from Northern Virginia Community College.
Okay. Oh, okay. Okay. Sorry, I just saw your last name, and I used your last name instead of your first name. I apologize. Yeah.
Well, I am from Costa Rica, actually.
Oh, okay. Yeah. Well, I'm originally from India. That wasn't the. I just wanted to know which part in the U.S. or where you were. Just curious. Yeah.
Okay. Yeah.
Okay. So I'm going to talk about my experience using LaTeX. Just jump right in and use all the resources that's out there online. And during that process, I have created some lab manual, which Nathan and Tim and Joel have seen. Of course, it can be improved. And then also for one of the circuits class, one of the lab manuals has circuits included in it as well. So I'm just going to share with you a typical file, how is the flow of information in that file, and what is the product it produces. And recently I also discovered that you could create PowerPoint-like slides using LaTeX. So let me share my screen. And I will not show you the PowerPoint. But instead, I will share with you. So do you see the PDF?
Not yet.
Oh, okay. What am I sharing then?
There we go.
Okay. All right. So this was created entirely with LaTeX. Okay, and I'll show you the code in a little while. So LaTeX, as you know, Tech is the very old version, which was developed by, I think, Donald Knuth, and then Leslie Lamport improved on it, and you now have the LaTeX. So for example, you could create a PowerPoint-like slide totally with LaTeX. And this one, you can see there is a particular style in the background with some of the text highlighted in yellow, and then you have the border, which has some color. So this is what is called the theme. And then I will show you what theme I have used here. And before I proceed, there are a couple of distributions I have used. In fact, Nathan was referring to the third one, Overleaf, which I haven't used, but I use MikTeX. So if you want to download it, I'll jump to the old PowerPoint and show you where you can download MikTeX from. So you should be seeing these 2 links, miktex.org and techstudio.org. So these are a couple of distributions. So this does a whole lot of things for you. It includes an editor, right? And then anytime you ask for a package, it can it can automatically download it for you, or at least prompt you that you're missing a package. And then you go and search for it and then include that package. And then it will compile the tech document and then produce it as a PDF, if that's what you choose to do, right? And it can also both can allow you to include images, hyperlinks, so on and so forth. Of course, mathematical equations, which is the standard staple of all the tech distributions. Okay, so that is the whole scope of these two flavor of tech that's out there, and this is all open source, right? So that is where tech has a big advantage, in the sense it's open source, so you don't have to pay anybody upfront to have access to it. Okay, so now let me go back to the PDF. Okay, so for example, this PDF has text, and then it produces a contents page, and these contents are alive in the sense you can click on them, and then it will take you to the page where that is being discussed. Okay, so let me dial back. And then you can put some text here, more text with bullets. And then you can include some images, and I'll show you the code in a moment, but this is the entire capability of what your slides can contain. And then here I can have a link for a clickable video link. And then when I click on it, do you see the image?
Yes, I think so. It's loading. But now it disappeared. Ah.
Oh, there we go. Did you rebuild the double pendulum?
This is a coupled pendulum.
Oh, is that a spring
Right.
between the two?
Okay. All right, so you can have video links. Then you can also reference to an external site, which is the next one. Okay, so you should be seeing a YouTube link to a NASA website.
This was an incredible landing to watch. That thing is the size of an SUV. It just blows my mind. And the little helicopter that they have on board is capable of like complete autonomous flight. Like there's no operator who's like with a joystick, like completely flies on its own. Just, it's insane.
Okay. All right. Let's now go back. I can close them. Oops. Sorry about that. Okay, so what is the underlying code, right? So let me open that file. It is really slow today. Okay, there you go. Okay, so I'm using Text Studio for this demonstration here. So first, this could be your only file. For example, it could include all the bibliography you want to have. It could include all the content. Everything could be in one file. If it is simple enough, you could do that, right? So in this case, the first thing is you have to specify a document class, which tells you what kind of document is this, right? Is this a slide set, or is this an article, or is this a journal article, and so on. And some of the journals have their own document class. So you will have to import the document class and the style files associated with it, and then work with it, right? So that the final product will be in accordance to their format. Okay, so in this case, this particular document class is called a beamer. And there are other document classes as well, such as, I think I saw one called slides or slide sets. So again, you have to be very careful because some of the document classes may not be compatible with the particular version of LaTeX you're using. So you could run into those traps. The second piece of information you want to specify is how to include graphics. So that's the second package you might need. And then in this case, I'm going to link from my document to something outside the document. So you need to have a package for that. And then this MD framed, I wanted to put some content in a box. So that's why I have this package here. And then this one, I'm specifying a theme for my slide set. And this particular one I'm using is called Ann Arbor. So if you want to know more what other themes are available, then you can go to this website. Okay, and of course this entire talk is being recorded, so you can or I can send you the tech content as well if you want. Okay, so that tells us all about the themes that is being used. So this essentially what this does is where the text is placed, what font, what are the border colors, and so on. And then here I specify the title in bold. And also LaTeX itself is a keyword in the sense okay, and all the keywords are expressed with the backslash and the keyword following it. And you have to type it exactly the way it is specified. So if you make something uppercase where it is meant to be lowercase, it may start complaining. And then /large says that all the content that follows will be in uppercase. And then you have the author, the institute, the date. And here you can have a fixed date, or you could keep that updating with each day of the week. So this is what is typically referred to as the preamble, right? So sort of the introductory part. And then comes the main document itself. So it always starts with begin document and then ends with end document. One thing I like about Text Studio is once you type, /begin document, it immediately gives you an end document as well. So you won't forget. So in that sense, this seems to be better than MikTeX. Okay. And then this slash title page is necessary so that whatever is here will be part of your slide set. If I don't have the slash title page, then this entire thing is not visible anymore. I just discovered that. So, okay. And then comes each section, right? And each section is a slide set by itself. Okay. So the first section will be just the outline with the table of contents. So that is this slide set here, this one. And then the next one is the introduction, where I have this itemized content. So you just say, and here, when you want to itemize the content, everything is bookended between this begin and end. You say begin itemize, end itemize. And then here, I'm not enumerating it. I'm simply putting a bullet. It's just a bulleted list. Okay. And so you specify that by using this keyword slash item. And then you type the text you want to appear. And then the next one, this is the yet another slide set. So if I want to enumerate it, so instead I could do this. Okay, it automatically filled and enumerate. So let's compile this. So to compile this, you have to click on these green arrows here. So it does two things. It will compile it, and then you can also view it as a PDF on the sidebar here. So let's see if it does without complaining. Sorry, I didn't anticipate that. Yeah, it is installing a missing package. A lot of missing packages. Well, this is what happens if you try to change things on the fly. Oh my God. Well, it seems to be taking much longer than I was hoping. So let me stop this compiling and then go back to itemize.
Call from Surprise Lake E.
Oh, just a
Call
second,
from
please.
Surprise Lake E.
Okay, so sorry. Yeah, there is somebody here to deliver some appliance we had ordered. Okay. Okay. Yeah, so I think it had compiled. So here is the resulting document. So again, when you just say itemize, it is only going to give you a bulleted list. Okay, and then when it comes to including graphics, again, the new section is the beginning of a new slide set. And then here you specify you're going to include a figure, and then you provide the path. So the keyword here is \include graphics. You specify the height and width, and then you also provide the link to where the file is located all the way, right? Okay, and here is the key thing. Normally, when you copy and paste the file location, it'll have a backslash. Instead, you should put a /. Okay, otherwise it is misinterpreted. So just keep that in mind. Okay, then on the next slide set, I have a link to one of the animations or the the video of the oscillating spring. So this is how you can specify it. Here is one way. Okay, and this // implies that this file is in the same directory as the tex file. So that's kind of a shortcut. You don't have to specify the entire file path.
Relative paths versus absolute paths.
Right, yeah. And then the last one is where I'm linking to one of the websites. Okay, and then you end it with the end document statement. Okay, you know what, guys, I'm really sorry. I'm going to come back. Nathan, do you want to continue with Overleaf?
Yeah,
I'm really sorry
sure,
because they want to install. I don't know, they picked this time of all the 24 hours they have.
Yeah, absolutely.
Yeah, so it shouldn't take more than 20 minutes. I'll come back and resume.
Okay, all right, perfect.
Yeah.
Sounds great.
Yeah. Sorry about that. Yeah.
That's okay.
Yeah.
All right, cool, guys. Yeah, so that was one particular text editor that you can use. Whenever I'm writing something up, and I don't take advantage of LaTeX nearly as frequently as I could, but when I do, I use Overleaf. And Overleaf is nice because it's browser based. So you don't have to worry about like downloading anything onto your local machine. You have access to it anywhere that you have internet. And I mean, it just seems like everything's going cloud-based now anyway. So why not go cloud-based here? But so a lot of the same stuff still kind of applies as what Dr. Ramachandran was saying. So this is a paper that I'm currently trying to get published right now, but I can show this to you as kind of an example. But like Dr. Ramachandran said, you have to specify your document class. One of the other really cool things about Overleaf is they have templates that you can pull from, so you don't have to design something completely from scratch. I can kind of show you what that looks like after we look at this document. Then again, there are all these use packages. If you're familiar with like any other kind of programming, like if you do any Python programming, you might have to import modules or things like that. The use packages are kind of like modules that you might import in Python or another programming language. So it's kind of a pretty easy analogy to that. Then to provide notes, though, they use the percentage sign, and that's how you can notate your code as you're going through. But again, this particular document was provided through a template. So a lot of the things were already built in. The title section, the graphics path. Actually, I think I had to put graphics path in there. But graphics path is it calls to that package that we have included, and this lets us know. It lets the compiler know that you're going to be using images in the display in the article. But yeah, and then basically you can just kind of, I just copy and pasted a lot of my text in here. Obviously, it has some grammar checks, some spelling checks, which isn't really that useful since again your code, like it's still going to get tripped up on your code and on different notes that you write. So it might be kind of more annoying than anything really. But I mean, it really just kind of allows for like really solid formatting, really good professional looking formatting. And let's see if I can try. So again, and so this is an article, right? Unlike the PowerPoint slides that Dr. Ramachandran was showing. So each section is essentially just a section, and then paragraphs get broken down just like they are. So that backslash, again, like when Professor Ramachandran was talking about, like anytime that you're designating a path to a file, you should be using /. And that's because the backslash is saved for the syntax in LaTeX. Anytime that you backslash something, the compiler is going to be expecting one of those LaTeX specific keywords. It is also used as an escape character in the event that you want to use a symbol that might have another meaning in LaTeX. So again, like I said, the percentage symbol is typically denotes like notation. So if we get rid of this, you can see the entire thing goes to green, which is the color of their notation. So if we just throw a backslash back in there, the escape character recognizes that the percentage sign is actually going to be used in the document. So some other really cool things about LaTeX, and again, Overleaf I think makes this pretty easy, is it's pretty straightforward to include mathematical notation, mathematical expressions. And so the syntax for that is, it's pretty straightforward and easy when you get the hang of it, but it looks a little jumbled. So any mathematical expression is going to be sandwiched between a backslash and a square bracket. And then you can see at the end, backslash and a square bracket. And so that's how it knows. And this is kind of confusing because I feel like in a lot of other computer programming languages, if you had backslash bracket at the end, you would expect bracket backslash, but it actually just goes in the exact same order. But here is how you would do a subscript for a variable. So this comes out as J sub thermionic. The caret, like usual, is how you would do an exponent. If you want like a fraction in your exponent, you have to make sure that is included within curly brackets. So like we have right here, we have e to the, and then if you want to do a fraction, there's a special keyword for fraction. Then for your Greek alphabet, there are special keywords for that. And then, in the denominator, then we have, the Boltzmann's number, constant, whatever it's called, and temperature. And then, again, like this is a formatting tool, so it has a lot of keywords that are specific to formatting. So Q quad will give you 2 single spaces. If I removed one of the Q's from here, just quad, that would give you 1 single space. And so just to create a little bit of space over here between my equation and the notation saying this is the first equation in the article, it just kind of helps out with the formatting. A lot of articles will not be indented on the first paragraph, or in like, you might have a mathematical expression inside your paragraph. And so when you pick back up with text, you don't want to indent again. So they have kind of a nice little no indent command here. So again, the mathematical expressions are a little clunky. It's a little different. But again, what we're working with here is a text formatter. So, putting mathematical expressions in is kind of a secondary thing. And so, there are a couple more hoops that you have to jump through. Another thing that's kind of cool. So there are other packages that you can, load in here. Again, in this one, I had to add this wrap fig in here. And what this essentially does is when I provide a caption, no. Wrap fig actually will cause the text of the body of the paper to wrap around an illustration or an image that you include in. And so in this little bit of code here, we can say, hey, we're going to begin this. We want the figure to be on the right-hand side. That's what the R stands for. The text width, we want to give it 0.25 inches. We want everything to still remain. The centering might have to do with the caption. It can be a little unintuitive about how some of these commands interact with their given packages, because there isn't necessarily any notation that's telling you what package this is calling. So sometimes like really understanding what's happening can be, kind of have to play with it, get some kind of trial error down to really figure out what you're wanting to do. But then, including the graphic, this is the text width for the graphic itself. This is the path to the image. Now, one of the things also that I like about LaTeX is you could specify an absolute path here onto your local machine, or you can upload images into the document that you're working on. So every document that you start will have like its own directory here in Overleaf, and you can upload images directly to this directory, and then you can call from the directory that you're in. And I think it's just a little more straightforward, a little less confusing about like making sure that your file path is correct to your local machine. So this is kind of a cool option. It's really easy. You just hit upload. You can browse from your computer. You can pull something offline, whatever. You just upload it, and then that will save it right in this area. It is contained in my folder images, which is again is in the same directory. And so then the path is just images and then what the JPEG file is. So it's pretty straightforward. It's more math stuff. That is just the next image that shows up down here. See if there's anything else specific. So you can do sections, you can do subsections. So I have a section called advances, and so that gives you a bold, kind of a larger font type. Then when we go down to subsection, materials and fabrication, you can see it's still bolded, but it's the font size is a little bit smaller. Then you can go all the way down to subsection, which might be kind of difficult to distinguish between the two if they weren't right next to each other. But you can see semiconductors down here is a little bit smaller than materials fabrication up here. More images. Let's see here. I think that's probably the majority of like the actual body in here. But some other things that you can do, again, kind of in the formatting here. So obviously this is where my title is, but then you can see this running title, thermionic emission. This is, on the odd pages, because this is going to go in a journal somewhere. You have kind of the subject of your paper, and so that's going to pop up on the odd page of each one. And then the title of the journal, that had to be put in somewhere a little less intuitive. I think that might have gone in here somewhere. So again, the nice thing about the template was again, all of this stuff was already built in. Literally, I just had to go find the individual field that I wanted to change and just swap out the text. Otherwise, if you wanted to make this document from scratch, you would have to build out this back end coding for it. And then you'd have to build out this front end. And then it does also have a page for references, so you can create a bibliography in here. These are not my sources for this particular paper. This again was pre-made. But that kind of gives you kind of an idea about how Overleaf works. Anytime you make a change, you can hit recompile, and it will upload your, I don't know. some random text in there, and then recompile that. And then the compiling happens pretty quick, which is nice. Obviously, the more changes that you make, the longer it might take, but it just updates real easily. Back to, and we can put that. So we can go back to kind of the main menu, or see if I can find my way back to the main menu. Maybe it is. Oh yeah. So all right. So we go to new file. Sample, create. Oh, I just put that in here. I don't need that. Take that. I'll get back to the main. And I don't use this as frequently as I could. Let's just. All right, there we go. All right, so this is kind of like my dashboard. It shows me like the different projects that I have working on here. And so your account, you can get like a paid subscription or whatnot if you want to. This is free. The version that I use is free, so it's kind of another cool thing about it. So if you want to start a new project, again, you can do a blank project. You can upload a project. You can import things from GitHub. And then these are a variety of different automatic templates that they pop up. There's a whole bunch more. But academic journal, your resume, CV, your thesis, a lot of different options that you can do. So, I mean, if we picked resume, CV, and it provides a variety of different templates that you can choose from. So Mona Lisa apparently used that one. And then there's just pages upon pages of different ones that you can pick. Just say we pick this one, open it as a template. And then boom, again, here's all the documentation, all the stuff that's already been built out. And let's see, so they've got all of these sections built, so we can just go down, begin, document, name, address section, name at the top. Okay, so if I wanted to put my name in here, learn how to spell, then, and I mean, it really is just that's simple. I mean, you just go through and you swap out the info. The other really nice thing that I like about LaTeX, and Overleaf specifically, they provide a lot, although you can find it elsewhere, is their documentation is great. So again, like if I wanted to know how to do Greek alphabet in LaTeX Overleaf, bam, list of Greek letters and math symbols, click on it. And just the documentation is just really, some of the best documentation that I have encountered. It's just very easy to read, very easy to make sense of. And a lot of the symbols that they use are pretty straightforward. I mean, it's nice. Like the difference between a lowercase delta and an uppercase delta is really the difference between a lowercase d and an uppercase d. So not all of it is like really intuitively written, but a lot of it is. So a lot of different symbols that you can use. And I mean, again, they just have all of these different guides and documentation that's built in. Everything from like image uploading to bibliography management, different languages, document structure, glossaries, indices, formatting, like anything that you could think of, they probably have documentation for it. So it's kind of one of the things that I like about it. Again, this is the one that I typically use, although it's going to be really annoying if I can't figure out how to get back to where I was going, or get back to my dashboard. But yeah, does anyone have any questions about Overleaf or anything that I kind of just covered about that? No? All right, cool. Well, Dr. Ramachandran is back, so I will go ahead and turn it back to him. Oh, there.
Okay. So hi, Nathan. Yeah, that was, I was just listening to parts of it. So did you cover using subfiles?
How do you mean?
Okay. All right. So let me then show an example. Let's see if I'm sharing a screen. Okay. So, all right. So we talked about creating a slide set with LaTeX or LaTeX as I don't know which one. Is it LaTeX, Nathan? I didn't really delve into the history of it.
I've heard it pronounced every way that you could possibly imagine. I have
Right.
no idea what's right or whatever.
Yeah. Okay. All right. So here is a document which has, there's one principal document, if you will, where I refer to all the packages it is going to use. Then I also cite where my bibliography is. So that is where all the references and bibliography is going to live in that document. But then, and of course, there is a path which specifies where all the images are going to be. And I saw that Nathan was showing some examples with JPEG. You can include JPEG, and all the ones I have included here in these files is as an encapsulated PostScript file. Anyway, that's beside the point. But this main document also branches off to several subfiles. So you could do that also. So for example, this jumps off and refers to a subfile called gates.tech or flipflop.tech, right? So let's open those. Okay, so this is what, for example, gates.tech would look like. Here I say, what is the document class? So I had created a document class for one of the other labs. So I'm using the same document class here. But then I'm also saying it's one of the subfiles, right? Sorry, I'm specifying this is a subfile for this main file. That's what I'm doing here. And then this has its own content. And one of the important contents is here. Oh, there is one package I want to cite. I'm also having circuits built here. So let me tell you what that package is called. You can generate circuits.
You can actually actually create your own circuit diagrams in here?
Right. So this is the package,
cool.
use package circuit IKZ. And yes, you can. And here is what it will look like. So I'll show the PDF that was generated. So are you able to see the circuit?
Yeah.
Okay. So this is this is the content of that file called gates.tech. So it is showing an amplifier circuit with two transistors. Sorry, it's not an amplifier. It is it's a gate. Yeah, it's an AND gate. And then it has two input. It has some capacitors to filter out noise. And then here is the output. You can visualize the output by operating an LED. So when there's a high voltage here, the LED will light up and you will know the logic is working the way it is supposed to. So you can, so the way you specify this is pretty elaborate. You have to tell you have to specify in LaTeX there is a resistor between this node and this node. There is another resistor between this node and this one. And you also have to specify the sort of the coordinate location, if you will.
Like I said, it really makes you kind of have to really think out your circuit design.
Right. And then here you specify, now I'm going to have a transistor and one of the nodes is connected to this pre-existing node, right? And so on. So all those gory details are specified here. If you go to this get.tech, let me clear all the drawings. So this part, that is where I'm, okay. So here you're saying this entire section is describing a circuit. So it starts with begin circuit IKZ / draw, and then end circuit IKZ. And within this, I'm saying there is an NPN transistor. So in this node, there is an NPN transistor. I'm going to call it NPN1, and it will be labeled as Q1. And one of the nodes is at 0, 0. And then there is another node, which is to the east of this node. There is one to the south, one to the north, and so on. Right. So for example, each transistor is described by 3 nodes. Three nodes and a reference node, right? So 4. And then here I say, draw a line from this coordinate to the next component, which is a resistor. So this is a keyword. Okay, so this capital R is a keyword. Anything within a square bracket is a keyword of sorts. So here is a short, which implies it's just a wire, and C implies a capacitor. CARC implies a node. It is something which you indicate to the reader that this is where you would measure some quantity, right? So that's why you have that. And ground is the ground node. Then you really describe, from which coordinate to where the line is drawn.
And these particular keywords are all like specific to that circuit's IKZ package that you've
Right.
included.
Right, correct. Yeah, so again, some of these are labels. I think this VCC, this, let's see, which is a keyword and which is the label. Yeah, I think this one, the one within the square bracket is a keyword, and anything within the curly is the label which you are using. Yeah. So this is also possible with LaTeX. Right. Alternately, you could draw the circuit elsewhere in some other program and then include it as an image file.
I mean, this is a perfect example of like, again, those packages being like modules. If you've gotten into like any Python modules, you know that you could spend hours, days, weeks just learning the particulars of that particular package.
Right.
So, this one seems pretty sophisticated.
Right. Yeah, I was pleasantly surprised that this is possible, and look at the quality. It is so good. It's very sharp, but I think that I'm still figuring it out. But the trick is to specify the coordinates correctly so that you suddenly don't have a line that goes like that.
Yeah.
Yeah, and so here then I can place the questions. This is all done through that MD frame command, for example. So here you can place some questions and then highlight it so that the reader would know what to look for. Okay, so that is another sort of use for LaTeX in writing lab reports and lab manuals. Let's see, is there anything else? Yeah. Oh, okay. Yes, I started talking about subfiles, right? So the one I showed you, the PDF I showed you is for one of the subfiles called gates.tech. And then the second subfile, where is the second subfile? The second one is called flipflop.tech. .tech. Let's open that. So that got compiled, and here is the PDF corresponding to that. And here I don't think I have any diagrams. It's mostly text, entirely text, in fact. Okay, so you can in fact compile these separately, or you can, okay, or the other possibility is you can compile this parent document, which is bfis 432 labmanual.tech, and that will automatically compile all the subfiles as well. Okay, so the advantage here is I don't have to deal with one humongous file. Instead, I can kind of split it into different subfiles. Okay, any question?
Anybody? All right, cool. Well, awesome. Well, I think that was like a real great, kind of walkthrough with some of the things that are possible in LaTeX and different capabilities that it has, some different uses that we can make of it, and a couple really good examples. So, thank you very much, Dr. Ramachandran. I really appreciate you taking the time to put together that presentation and kind of walk us through some of the things that you've done with LaTeX. And we just really appreciate your time.
Yeah, absolutely. Yeah, and if you have any questions, particularly if you want to draw some circuits and you're looking for some examples, I have a few, not a whole lot, but a few. You can look it up.
Awesome.
Yeah.
Awesome. Cool. Well, I think that about wraps everything up. And the only other people who are in attendance right now are two students who aren't from UW, and then the club officers. So as far as club announcements, I don't really think I have anything relevant. Anyone have anything before we declare this workshop over?
You will keep giving notice whenever you're going to, there's another workshop, right?
Yeah, definitely. So, so this is the last week of our winter quarter. We're going into finals week next week, so we will not have a workshop next week. The week after that is going to be our spring break. We will not have a workshop then, but we should be picking up with workshops that following week. So 3 weeks from today will be our next one, and I'll make sure that I keep posting them on the SPS server as well.
Awesome, thank you. And thank you, Professor, for the
Oh, you're welcome. I hope it was useful in the sense like a workshop is meant to give you some actionable ideas. I hope it helped.
Absolutely, definitely.
Yeah. Okay.
All right, everyone. Well, again, thank you very much. We hope to see you guys again soon, and have great finals and great spring breaks if those are on the horizon for you. And again, hope to see you guys soon. Thank you.
Okay. Yeah. Welcome. Yeah. See you. Thank you, Joe. Yep. See you then. See you all.